Good morning, everyone. My name is Isarul Haq. My CAD is K00369285. I'm going to here to present machine learning and its basics and what are the other algorithms that we require to understand what is machine learning in today's world. Let's start and begin. Why learn? Machine learning is a programming computer to optimize the performance using data or past experience. Like suppose we are creating an algorithm which uses the previous data that we collected that are very cheap and in abundance to understand what's going on, and using all those data we can automate something which requires very less number of time, using as like predictive analysis, using the fault tolerance, whatever the thing that is going on. there's there is no need to learn to calculate the payroll because those are simply addition multiplication. Learning is used when we use human expertise, like recognizing voice, because we are learning from previous recognition of the system, solution in changes in time, solution needed to adapt particular cases, solution using the hierarchy, and various other things like the biometric, like the pattern which is going on right now. So this is why we learn. We learn from our past experience. Let's go to the next slide. What we talk about when we talk about learning. Now there are different examples based on learning. Like suppose data is cheap and abundant. We are storing numerous data like the Amazon, AWS, Twitter, and everything. So every data is collecting nowadays. Earlier we don't used to collect like this much of data. What are we supposed to do with this data? Right now, multiple like MNC multinational companies are collecting all those data and trying to make sense with them. Like suppose if they are using data like for a Twitter for a particular trend, so they get a particular spike at a particular limit of time. Like suppose a video went viral. Because of this, there are like thousands and millions of hits going on like YouTube, like in Facebook also. There are fake account also. There are spam also. Using all those filters, we can optimize our coding. That's called learning. We call machine learning. Now suppose customer transaction to customer behavior. People who bought the Vinci Code also bought five people you met in heaven from the Amazon. So we came to know from the past experience that people who bought this also bought this. So there's a trend setter, like what we should recommend also. Like if a person who is the next person who is going to view the Vinci Code, we're going to show him this book also and recommend that the people who bought this also. So building a model which is good and useful approximation to make a data which makes sense to sell something and to even to gratify that thing. Now all this machine learning is nothing but internally is knowledge data mining. It's a non-trivial process of identifying valid, novel, and potentially useful and ultimately understandable pattern in data, as said by the scientist Fayed. Now there are multiple applications. As from the very beginning, I keep on telling you what is the use of this machine learning and how do like they're going to help in the nearby future to all the customers, to the layman people and everything, even the business people, the local people, the entrepreneur. In retail market, it can be used as market basket analysis. CRM, which is known as customer relationship management, like market based and like in a stock exchange, like if something changes happen because of one particular variable, the whole trend set goes to down or goes up, there's a spike. Similarly goes to the relationship management, like if a customer came with a particular app and this app is targeting only a specific people, is it gonna be in a particular region or in a whole global area? In finance also, credit scoring, fraud detection. In manufacturing, optimizing, troubleshooting. In medicine, medical diagnosis. Telecommunication, quality of service optimization. Bioinformatics, motive and alignment. Web mining, search engines. Let's go to the next slide. So ultimately, what we understand, like as if I ask you right now, what is machine learning? The simple and in a very brief note, machine learning is study of algorithms that will improve the performance at some task with previous experience from the data that we gathered. Now, every now and then, there is no specific algorithm for a machine learning. There can be a different version, like thousands, like hundreds, and algorithms that we jumbled up all along with combining one into another, thereby optimizing a performance criterion based on different criteria, different priority, different past experience. The rule of this statistic is inference from a sample. The sample can be like a different variety of that. The rule of computer science, efficient algorithm to solve the optimization problem, representing and evaluating the model for inference. Now, how the growth of machine learning has been increased exponentially from year to year. Machine learning is approach to speech recognition initially, then natural language processing, then the computer vision across the AI, then medical outcome analysis, like how these things are helping each other, the robot control, the fault tolerance, because you're learning from your fault. Actually, what it means, like the once you get like the thing is not ending, you don't do it again. That's because this how we learn as a like a small born child, like a young child, young infant. Computational biology, this trend is accelerating. Improve machine learning algorithm by creating new algorithm, new dependencies, improve data structure, networking, fast computer analysis. Software too complex to write by hand, definitely, because we never learn. So we need to automate this using new sensor and IO device, demand of self-customization to users and environment. It turned out to be difficult to extract knowledge from human experts, failure of expert knowledge in the 1980s. Okay, so day by day, these things keep on learning. So it's basically the good thing. Now, what other in application for this machine learning can be categorized into four special things: association analysis, supervised learning. It can further be categorized into classification, regression, or predictive analysis. Unsupervised learning, where the simple criteria doesn't occur, even though it's happening. The reinforcement learning. We're going to deal with them in detail in our next paragraph. Now, learning association, the first, that is also called a basket analysis. Now, suppose they have a probability that someone who buy X buy Y also, where X and Y are product and service. For example, the person who buy chips around 8 to 9 p.m. also buy beer. The probability for that is zero point 0.7. So we have a different ID for every group of things. The market, the people buy during particular time limit. Like first item is bread and milk. The person who buy bread gets milk also. Person who buy bread and diaper gets beer and egg also. Free milk, diaper, beer, coke. So in all these things, the something is all related. So how do we classify? We classify using the high risk, the low risk, credit scoring, differentiating low risk and high risk consumer according to the income, the low risk and the high risk. So in order to that, we created a graph, high risk, low income, and what the low risk. So we categorize further. The classification application are facial recognition, character recognition, space recognition, medical diagnosis, and this. So everything is dependent. You have to make sense with the data using the algorithm. The face recognition is training an example of a person, then making a test image. Training sets are simple to make the learning, where the algorithm learns from the training set, and tests are the actual data set where you test the prediction. Now we come to regression. Regression is the price of a car that attributed using the line formula that Wx equal to y naught. Then making a gratitude and the parameter, we use the graph. Then the regression application, the angle of the steering wheel, similar to that, but we are doing in a further different language. Now supervised learning uses predictive of future classes, knowledge extraction, compression, and outlier detection. Exceptions of those are not covered by the rule also. Those are called supervised learning. Unsupervised learning, normally what happened? No output. Clustering of the similar group, not clustering. This is how I summarize my whole machine learning. Bioinformatics are the motive for this. Thank you.